or another from PG. Hey, where is the PG actually? P stand for what? Cannot be a Penang, right? Do you see his name here? Sorry, this student, Dyson Leong Chat Singh. Are you from Penang? Let me see. I think the classroom doesn't have any student for Penang. P78. KL. JB. I can't find your name here. Are you a student or what? You must be a student, right? Looks like. Stranger. PG is not on the list here. I don't know how to mark your attendance. There's no more. I don't know. Okay. We also have 2 students from PG here. But on my list here, I can't see any student here. So let me ask our CC for a while. Hold on. Okay, never mind. We have to go ahead and start right now. Okay, so today, what my planning is, after I got experience from the previous class, we will do it together. So you are not just watching, we are all doing it at the same time. So you try to follow every step that I'm doing right now. Okay, so the first thing here, since this is to prepare for your lab number 2, and lab number 2 is due later, right? We due the assignment 1 is to be due first, then after that will be lab 2. But this today what we're doing is for lab 2 usually. It's not for the assignment number 1. So let me show you something about the assignment 1. You're kind of confused. We are doing 2 assignments at the same time. This is what happened when they squeeze. They squeeze all into a few months now. They're trying to reduce the number of needs and the time also. The total time they also reduce. Usually, from the previous years, we have 5 units and at 5 different sessions. But this time around, we have only 4 units. That's why they squeeze the lab 2 into after the unit 1. Okay, where can I? Oh, actually, I received the reply. Okay, I received a reply from the our CC, and she said that the student from Penang, actually you should join the Penang class. So if you want to take a look here, it's okay. But actually you should actually attend the other tutors class. But I don't mind if you stay around. Because here I'm conducting the class for the Ipoh, JB, and KL. I think Penang they have another tutor. Probably they over there got many students there. Okay, what you should do now actually. Wait a minute. Where is the let's check the to download your assignment. Usually it was here. Last time I saw it. Something called the class assignment here. Okay, if you look at assignment one has no lab, right? Only assignment 2, but the assignment due date is I think next month or something. So this is assignment 1. There's no lab for assignment 1. You can see today we're doing assignment 2. All right. So assignment 2. Altogether we have 5 labs, I think. This is the last one. I think this is the last one. Together we have 5 labs in assignment 2. And okay, how come? Oh yeah, this part 2. Today we have 5 labs. Yeah. So this is lab number 5. Lab number 5, question 7. Okay. But today we're going to focus only on lab 1 and lab 2. We're going to leave 3 to 5 to the next lab session, which would take about 6 hours. Today only takes about 4 hours. Probably we could end it earlier. Usually we can end it earlier, end it about 11:30. All right. First thing is to create the blank sheet. We call the MS Word files for assignment number 2. Okay. So on the first page here, we need to put down our plagiarism declaration form here, and then our name, student ID, and all others details. So what I will do here is I'll borrow from the previous student. Okay, later I think you can do this yourself also. It's right here on this so-called Flex Learn. They launched it this semester. Flex Learn. You come here, you log in, and you come to this electrical circuits course, and here you can download this blank plagiarism form here. All right, then you need to fill it all in here. So what we do is I'll copy this. Okay, and paste into the new one. All right, then I have the insert the page break right now. Okay, so this question, I think start from question 3, if I'm not mistaken. Let me double check. Question 1, we haven't covered yet. Okay, this on unit 3 or something. Question 2 also. So the lab actually is a question 3, 15 marks. Lab 1, this is what we're going to do it right now. Okay, so I'm going to leave one page here, empty page. Later I can add in more, and then I'm going to have another page break here. I hope you can see it. This for question 2. Okay, another page break for question 3. Okay, so today we're going to focus on this question 3 here. Let's copy the title here. So I hope you can do it together. So if you watch until the end, then you start following the video, then you need double times to do the assignment. So I will recommend you to do it together with me. Are you ready? Are you ready to start the lab? Actually, the lab is pretty easy, but got a lot of things to do actually. Okay, in the process, you may ask question. If you are facing any difficulties, you may ask question. It's okay. Okay. Don't be shy. Okay, just ask question. And the best way to ask question, I think, is to put down your question here at this. They call the meeting chat here. Okay, you put down your question here, and actually, I can come and answer your question immediately. All right. So the first lab here, usually the students should read the lab report before this session. That means you should read before you come. So basically, what we need is only the simulation software called the LT Spice. Okay, and what we're going to simulate today is a very basic Ohm's law. So we talked about this in the previous session. We talked about Ohm's law and Kirchhoff's law. Oh yeah. Okay. So the first law here, we have the currents law. Currents law. Something about the nodes. Something about the nodes, right? All the current sum in the nodes should be equal to 0. All the current coming in or going out should be equal to 0. The sum of all the current. The sum of all the current minus the sum of all the one leaving. The one coming in and then the one leaving. The sum of these two should be equal to 0. Okay, that means the sum of current equal to the sum of current leaving, the sum of current entering, equal to sum of current leaving, or this one minus this one should be equal to 0, right? About the KVL, the voltage law, the sum of all the voltages in a loop is something to do with the loop. The sum of all the voltages in the loop here should be equal to 0. Okay, so this is the first circuit we're going to simulate right now. Okay, so are you ready? Before we start, there's something very important, because I remember last time when I marked the assignments, I saw the student, many students didn't follow these requirements. Okay, if you scroll all the way down to the end, at this report section here, if you read carefully, it said that you should capture results, every result actually, and then you can use a print screen, okay? And then your report should contain a short introduction. Just now, the introduction, what you are seeing here is quite long. You can see the introduction start from here, start from the theory part here, is all the introduction. It's quite long, right? But you don't need to do it exactly the same. You can shorten it to one or two paragraph, or 2 to 3 paragraph. Okay, what you need is just a short introduction and procedure. Procedure is important. Later we can borrow the procedure from this document. The results, okay, the result of the simulation, and most of the students, they forget about these two. The discussion and conclusion. You need to write down your own discussion on the result and the final conclusion of what is the lab about. What is your opinion about the result you are getting? And then you also need to answer this question also. You also need to answer this question and paste it in your report. Okay, so you can see now we have a few things we need to fill in here. All right, there's the thing I need to remind you. Okay, let's begin. First, when you launch LT Spice, I hope you already installed it on your PC. Okay, we have 3 more students joining us right now. Okay, before you begin, I hope all of you have already had this installed. When you first launch the LT Spice, then what you see here is an empty platform without any worksheet here. So you have to write left click on this icon here called the new schematic. Okay, on my PC it looks like this, a gray color background. Okay, let me close one. Just have one only. One enough here. Somehow it just opened 2. Okay. So the first thing here, I want to show you something easy first. Okay, from the start. How to get this register here from this platform? You can see right here, right? Something right here. So you just click and release the click, and then you bring out one of these register symbol here. So you just have another left click to release it. Okay, let's see how many do we need here. But I have something more easier for you to. Okay, let's all do it at the once here. So you see when you click, it's right here, right? The one on the screen here is horizontal. You can see it's horizontal, right? So we need to rotate this one. Let me try the command, Control R. So if you press Control R, you can rotate this symbol here. Okay, so I press it horizontally here. Okay, for R2 is right here, vertical, right? R2 is vertical. So I need to rotate here and place here. Okay, adjacent to this R1. R3 is right here, horizontally connecting the R1. R3 connect R1 and R2. Okay, and these are not here. So R3 should be here, right? So I rotate one more. I put R3. R4 is at the end here, at the right hand side corner here. R4 vertical, okay, rotate R4. The position of the text is not important. And then the last one is the R5 here, right at the bottom here. Okay. So I need to rotate. I press something somewhere right here. So after you're done, I think you need to cancel this command. I think by pressing the escape key. Okay, so the thing disappear. So right now, what wait for us to do is the connecting the wires to join all these wires together. Okay, to join all these wires. Actually, it's right here, right? You can see that wires. Okay. Let's join these two first. So make sure you got a solid joint here, right? It's not joined to the space. But for this one, I make sure that I can join this become a knot here. So this is the how it should looks like. You can use your scroll. If you have a scroll on your mouse, you can scroll to zoom in and zoom out. And this is a pen. You can left click and then pan the schematic here. Okay, zoom in and zoom out using your scroll. Okay, so I'm going to go ahead and join all the wires together here. Join all the components. Click the wires and start drawing the line like this. So when it's not joining, you can see you can extend all the way down. So if you click on this knot here, then it means it's already joined up with this component. You can test it with a pen. If you move around, but everything move together, right? Everything moves together. We can remove individual component here. After you place down on the worksheet, it stay there forever. I don't think we can move individual component. If I left click here, I right click, there's no effect at all. Only left click, only right click I can change the value, but the left double click has no effect at all. Okay, just go ahead and join all the components now. I hope you can follow me right now. This steps will be easy, right? These steps will be easy. All right, that's what we end up with. This is the first step here. This is the first step. Let's go back to the procedure here. All right, so we copy this thing here. I think we can copy. This is not any idea or something. This the procedure we can borrow it from the assignment. Okay. So remember to type in the introduction here, and then you need to do it later on. Right. So the next thing would be procedure. Okay, we do it together so that later on you don't need to spend any more time. So this is the first step here. First step. So on the introduction side here, I need to show you for one time what can you do about this introduction. Ohm's law. So introduction, I think you can talk about Ohm's law. Okay, and then you need to talk about Kirchhoff. Kirchhoff current law, and then talk about Kirchhoff's voltage law. Just copy all. Okay, you need to talk about all this. Probably you can borrow something from online I think it's better. But if you want to follow exactly the same, I think it's okay because this is quite general knowledge already. This is not something that is new or something. I think you can just borrow this one, but don't copy exactly the same. It's not nice to see exactly the same. But what I will do usually, I will copy the most important sentence here. So I will actually, this is the most important statement here. Okay, you can copy it down. You don't need to be italic. Then you can show something like in something like this in medical form. Okay, so we need this thing here. So what you can do is use these snipping tools here. Copy this equation. So it's a bit larger, so we need to reduce the font size a bit. Okay, try to match the font size between here and here, so that it will look like a messy. It looks like quite professional report. Okay, I think we still need some kind of a diagram or figure. So this is a good figure here. So we just copy this figure. Okay, we reduce it, resize it, so they look nice on the report here. And then we need to put the title, figure 1. First figure. And so we put down a bracket here. We say refer to figure 1. Okay, so here's figure 1. So we put this thing in the middle. Actually, it should be sitting right in the middle. So what I will do is I'm going to move this one to the center, centerize the thing. Okay, so this is a short introduction. You can see the font size is different. This is not nice, right? The font size need to be same. We're using the 12 Time News Roman. Probably if you like, you can put this down also. You look better. So this I will call the short introduction. This is the very short already. I don't think you can shorten it some more, because I have the definition, the mathematic form, and the figure showing that this is the diagram, this is the equation. Okay, and these are words. These are the words to describe this thing, and this is the formula equation to represent this diagram. Okay, so you do the same for KVL. All right, so for the first procedure, construct the circuit F figure 1.3. So to make sure this figure, we need to change it to figure 2. Okay, because this is a report, we submit it as a report, not as an assignment actually. Later on, you are. Let me show you something very important here. I hope you have to know the way how we mark the assignment is based on the something we call the OBE. Where is it? Okay. Later I'll show you. It kind of disappear from here. What I'm saying here is the marking scheme, how we do the marking is based on the how the report looks like. Is it looks professional? Is it look very messy? Is it include with introduction? So we look at all these detail. So you will make sure, even though your diagram and figure are properly follow the standard, okay, is really nicely put on the report. So we don't have figure 1.3 just now. We have figure 2. So the figure 2 should be this one. You can just copy it. You can just copy it, this figure right here. No, not this one. This one. Okay, just copy this figure 1.3. So I just copy it. Make sure you do it nicely. And put on your report here. This is why I just now I mentioned to you is it will take some time to get this done. That's why we have 4 hours here today. Okay, so right here you put figure 2. Figure 2. Centerize the thing here. Centerize it. Construct the circuit below in figure 2 using LT Spice. All right, so this is the first step. So before anything happen, let's save the document first. Sometimes when the battery is not good anymore, sometimes the PC can shut down anytime. So I'm going to save this one right now. I think you should do the same. Save the document before it disappear. So I save it under the LAB1 or TMA1, assignment 1, WOU ECP assignment. This is assignment 2 actually. All right. Now we switch from the report to the LT Spice now. Let's go back to LT Spice. As you can see, we still have 2 more components we need to add in. One is the voltage source, and we need to add 3 grounds. All right. So that way to find it. I think ground is obvious. Here's the ground. Okay, just take the ground and put it here. We need 3. 1, 2, 3. Let me double confirm. Yeah, we need 3 ground here. Exactly the same. Okay, let's join the wires. Let's join the ground with the wires. Click on the wires and join. This one is slightly. Oh, after I place it, I cannot move. I cannot move it. Let me try. Let's see. I can move this thing. You can see I cannot move the ground. So I need to cut this thing here. I need to cut this thing. There's no move, right? This is a copy. There's no move. So you need to cut it and then take a new one and place here. But when you place here, you probably it's not joining actually. So to make sure we join it, the way when you first put it down is very important. To make sure you join it, I think you need to draw the line and click on this box here. This is a tiny square box. Make sure they join up. Okay. If you're not doing this carefully, later on probably you have another issue. Something like the open circuit error or something. All right. Here is D, B. I think we can do some labeling also.
Sir.
Ah.
Sir, for the grounding, we still can put 3 lines, right?
Line. What do you mean line?
I mean for the grounding. You still put triangle there, right?
Yeah, triangle, yeah.
So if we put a 3-line short line, is it okay?
No, cannot. You need to use a symbol.
Oh, okay, sir.
You need to use a ground symbol. You cannot create your own.
We cannot follow exactly the
yeah, it's different because the round ground has a few symbols. Some looks like a 3-line, some looks like this. So but when you come to LT Spice, you need to use exactly the symbol.
Oh, okay, sir.
So that the software can recognize this thing.
Oh, okay.
Okay. If you draw your own, even though it may look like a ground, but the software don't understand what is this. Okay, so you need to delete this one. All right, the last one. I don't think we need to put down the label A, B, C. I don't think we need to put it down. Because later on when we refer to this diagram, we need to refer this as a R1, R2, R3, V1, V2, V3. As long as not right now the R1, R2, R3, they're all placed at exactly the same position. R1, R2, R3, exactly the same position. So I think this is already good enough. So you have to make sure the orientation of this number 1, 2, 3, 4, 5. The 5 at the bottom here, the 4 at the right hand side, in the far right here. You need to follow exactly the same, so that later on when we all refer to the same component. Let's say I refer to R4, we actually refer to this R4. So if you put R4 here, you're confused yourself later on. All right, this leaves us with the last component, the voltage source. As you can see, it's not right here actually. You can't see right here. This is a trick for the beginner. The secret is here. If something looks like the digital gate, actually, these are digital gates, AND gates, digital logic gates actually. But these mean components. So you need to click in here. You need to click this symbol, and then this thing will bring out the window here. Ask you to select components. We need to select our power supply, our voltage source from this window here. So where is it actually? It's something called the DC power supply. Okay, so but I already forget the name. But don't worry, when you put your cursor on, actually you can see the name here, voltage dependent voltage source. So this is not the one we want. Let's put on E2. Also not the one we want, G. Okay, let me guess. Oh, here, voltage. So the name is called voltage. And the last two here, I hope you can see it right here. You select this one, you click OK, and then this one will come up. So you need to align properly. Put the positive sign. Put the positive sign on the top. So I use the Control E to move the text left and right. Control E to move the text left and right here. Align this properly here, so that you can draw the wire later on. You see how I draw the wire to join them up? Click and click. Okay, now I consider done. On my part here, it looks like it's quite even though here is a bit squeezed here. Actually, I need to have some space, but it's okay. It's okay. But if you want to make it look a lot better, you can move this one to the slightly to the left. But this one it won't affect your result. It won't affect your simulation result.
So where you can select the components, sir?
Which component you refer to?
Where you take the voltage?
Here. You can see this symbol.
Okay, component. Okay.
You click, then you select voltage here.
Oh, you go to the component. Okay, sir. All right.
Okay.
Okay, thank you.
All right. So I have one student, he said that he installed the wrong LT spice. He said got only 3 options. So I don't know what do you mean 3 options here. The LT spice, the version, let me show the version. The version is, I think this is a 10. This is 17, right? 17. So this is 17. So if you go online, let me show you. Let me help the student a bit here. You type LT Spice 17. Download also, put down download. You bring you right to this web page here. I think if you just download and install it, depends on what PC you are using now. Are you using the Mac or Windows? Actually, it's quite obvious. You can reinstall it. Okay, reinstall the LT Spice version 17. Okay, for this student, IABAA from Ipoh. IABAA from Ipoh. Okay, some students say got move option. Let me see. Cannot be this one, right? Cut, copy. I don't see any move command here.
Hello, sir.
Let me hear.
Yes.
Oh. So this big head is really a move. Oh, it can move. Oh, okay. Okay, thank you. Because I seldom move this thing. When I get it done, I just move on. Okay. All right. So now you are at this state now. Okay, let's see the next procedure. Actually, we are a bit, I don't know whether we are behind or not. Okay, click the set the 5 volt and perform the let's just copy this sentence here. Copy this sentence and then copy to your lab report here. 2. Okay. Actually, it's not nice actually here. Actually, we need something called a bullet. I think it's okay lah. We can do it later on. You can do this later on to beautify your report here. So I'm now using the bullets from the MS Word. So that later on when I press enter, you'll give me the automatic give me the next number. Okay. Because this alignment is better, right? This alignment look a lot better. So what we're going to do here, we're going to perform the operating point analysis mode. Okay. When it comes to simulation, we have many modes we can select. We want to select the DC operating point. Okay, so you come back here. You simulate. When you click run, this thing will pop up. The thing we want is right here. Operating mode here. If you click OK, you cannot find the R. Wait a minute. Let's see the error command again. Cannot find the definition of R. Oh, okay. So we need to have the value right now. Now the things without the value, we cannot run simulation. Okay. There's one thing we missing here. After we construct, we need to key in the value here. We need to key in the value 1K, 1.2K. This is a 5 volt, I think. This is 5 volt. Okay, where is it? 5 volt. Okay, let's do it one by one, everyone. Right click on this V here and insert 5 in front of V. Okay. The same thing for the rest component. Right click on this R and click 1K. Better follow the standard K capitalized a bit. Okay, so here's 1.2K. Right click 1.2K. Okay, you don't need to key in the symbol here. The symbol here don't need to key in the ohm symbol here, the omega. Okay, you don't need to key in here. So here is 1K also. Change it to 1K. And here change it to 2.4K in the middle here. 2.4K. (1.2), the last one. Okay, I hope no more error now. Let's run it. Yeah, you see no more error. We have some reading here. We have some voltage and the current reading right now. You kind of like do the pen. Move this circuit a bit to the left side, and then when you run a simulation, the box appear at this side here, so that they all fit into one page. So what I'm going to do now, I'm going to copy and paste the result here to my worksheet, to my Microsoft Word here. So I'm going to place it right under the number 2. You can see that the text is really small. The text is really small. I don't think this is a good idea. If I extend all the way, over the margin here, I think I'm going to split into a two image. I'm going to split into 2 image. Okay. To make it look nicer, because later on when you become a engineer, professional engineer, you need to produce a report, nice looking report also. Otherwise, people will question you whether you are properly trained in the school or not. Okay, so I need to put it down nicely here, resize it. Okay, and put it as the figure 3. Okay, another one is the result. Copy the whole window here and place down here. Okay, and name it properly, figure 4. Okay, there's some alignment issue here. Let me put in right in the center. So here we should tell something, set the voltage, power, perform the operating point by creating, okay, the result is shown in figure 3. Figure 4 actually, figure 4. Figure 4. So the next thing here is to verify whether this result is correct or not. Okay, based on my previous result I'm getting from the lab, looks like this is correct. Okay, so the result we are getting here, I think is correct. And probably you have some doubts. How come some is a negative current? All right. Okay, so we have this student still facing a problem. Nice bar. Or probably you need to set your resolution. I think for this student from IPO IABAA, I think you need to set your screen resolution, because I think your screen resolution is too low. That's why some of the things hidden from you. So this student for IPO IABAA, you have the screen resolution problem, I think. Okay, you can change it. If you go to the Windows, you can search. You type display setting. Oh, not this one. Actually, it's under the display. But this Windows 8 is not so smart here. You can go right to the control panel. Go to the display. Oh, can't find here also. It's called the usually it's called the display. Here, display. Okay. And then you need to go to the resolution here to adjust your resolution to at least 1280. Okay, You try to do that. See if you can fix the problem. Okay. Now we kind of like want to find out why we have this negative sign, why this don't have negative sign. What does this negative sign means actually? Okay. So we need to find out what happened here. Which one is called the VN002? Where is it? Sometimes we can't tell, right? We can't tell which one is N02. This one we know. The current flowing through the outfall, referred to here, is the 0.0012. Okay, actually this one can be read as a 1.2 milliampere. 1.2 milliampere. Okay, and the current flowing through the R3 here also 1.2 something. 1.2. R3 and R4. So R3 and R4, their current are the same. R2 is slightly smaller. R2 is slightly 1.11 something, 1.11 milliampere. But we have the negative sign here. So this negative sign means that the problem is right now we don't know whether this sign is either go to the left or go to the right. Okay, we have no way to tell. Just on the simulation result here, we have no way to tell. If you follow the lab sheet here, the lab manual, the manual say that, how come the I think I need to copy this one to the copy this, press under here, press under the instruction 1, step 1. Okay, just now I put it down below, so I put this thing back to the step 1 here, figure 2. You can see the I1 is going to the right, I3 also, and I5 is going to the left, the direction. Okay, so this is the design by the what happened on the schematic is what we see here. But we come to the simulation, there's no arrow here. That's why when we getting all this result, there's no way we know that which direction is this pointing to. Is it pointing to the left or pointing to the right? Okay, now I'm going to try one more thing here. I'm going to try a different type of simulation. Okay, I'm going to try this transient simulation. For this one, I try 20 millisecond. Time to start 1 millisecond. Minimum time step 1 millisecond. Okay, now I click OK. Now I'm doing a transient. You can see the trunk here. Now I run it. Okay, this is a result. Nothing, right? So if I put my cursor here, I put my cursor here. I put my cursor here. I go back to the draft here. This is a VN001 is right here. VN001 here. Here. Just now I click here, right? And then you go to the result here. N001 is 5 volt. You can see the green line means 5 volt. Okay, just remove this one. How to remove this one? You right click and then you click delete. Okay, now I come back here. I change this text. I change the text to N01. Okay, let's test this point here. Now I click on this point. You can see the probe. This red color thing is the probe. Now I left click on this node here, and I click simulation. It show me the it show me a 2.672 volt. 2.672. You can read the text right here. The text right here show the exact value. 2.672024. Can you see the text right here at this corner? When you move your cursor along this green line, you can see it right at the bottom here. Okay. Let's enlarge this thing. Let's remove this blank one. Do some good alignment. Simulation. All right, so this node here is actually N002. So I'm going to insert one text here. N002 here. Let's try to move. Yeah, let's see I can move this text or not. Oh, it's not easy. Not easy. Let me try. Oh, okay, move it. Okay, move it to the left, a bit to the left. So N02 is the 2.6 also. Okay, this one 5 volt, this one 2.6. Okay. So now let's go to simulation again. Change it to the DC point, operating point. Click OK. Now we're actually changing the simulation. So when this result, N002, N001, N003, you know where is it actually? You know where is the thing. Okay, now I'm going to, this should be the N003 here. Let me see, is it matching the, here's called the C. On the schematic, it's called the node C here. But on the simulation, now it's called the 003. So I'm going to, it should be here. I'm quite sure it should be here in 003. It cannot be the ground because the ground is 0 volt. Because the ground is 0 volt here. It's not N3. Okay, now we need to find out how about the current. I'm talking about the current here. What is this R1 here? R1 is saying that it's negative. R1 is negative. I want to know why this, what is the direction of this R1. So I need to go back to the previous method I used. I go back to the edit simulation, I go back to the transient. Okay, I keep all the value intact. Okay, I come here. when I click simulation, and then I put my cursor here, you can see the arrow is pointing this way. You see the arrows, the red arrow is pointing to the left. It's pointing to the left. And then it says 2.309. It says 2.33. Okay, it says 2.3 something. 2.3 milliampere is pointing to the. It's actually pointing to the left. This one pointing to the right. This one pointing to the left. Okay, and let's look at the R1 pointing to the left. You look back to here. Here's pointing to the right. So negative will become positive. This is what I mean. What I mean is, let me show what I mean. Here is pointing to the right, but on the simulation, simulation is pointing to the left. Okay, and then the simulation, if you change back now to the change the simulation command, change back to the DC point. You run the simulation. You see the R1 is negative, pointing to the left. Negative what? 2.327. Negative 2.327 milliampere. To the negative, to the left is negative. So to the right become positive. This it tell you the negative because it assumed to the left, but according to our schematic is to the right. Okay, from the positive all the way to the right and then come to the ground. Okay, so the simulation, the bottom line is simulation says is negative to the left. So if you insist to the right, then you need to change this one to positive. This is what I mean. Okay, so you can say that let's find out another one. Another one is the V1. But V1 actually I think the currents will be pointing down. But we don't need to have the V1 actually. Another one is the R2. R2 is negative also. Okay, let's find out about R2. Go back to this simulation. Change to transient. Run. And put your probe near R2. So R2 is going up. The arrow, the red arrow is pointing upward. And then it says the negative. Just now it says negative here. It says negative. Yeah. It's pointing outward. Okay. So if you follow the schematic provided by this lab manual, is pointing downwards. So negative become positive. Okay. Okay, we cannot talk too much here. So what we're going to do is the result. Run the simulation and check the voltage or current and pointing the voltage. You also point at the node to check the voltage or node to check the current. Record the simulation result in table 4. So I just copy these two. I copy these two. I place it in my report. Record your result in table 1. Okay, just I delete this one to become table 1. So what is table 1? Right here. So what I'm going to do, I'm going to copy this table here. I copy this table to my let me move this one a bit up here. I move the table here, and then I can start typing the value. Okay, how do I insert the value? Let me show you. R1, the voltage across R1. Okay, let's go back to read the data. Voltage across R1. R1 is this voltage minus this voltage, right? This voltage minus this voltage is R1. N2 minus N1. N2 is 2. Actually, it's the N1 minus N2. Sorry, N1 is a 5 volt. Here's a 2 point something. So it's N1 minus N2. So I take 5 minus 2.67206. I get 2.32794 for R1. So I put it down here. I put it down at this box. 2.2794. Okay, so this is how I get the R1. If you want, you can put something like this. R1 is equal to V N001 minus V N002. Equal to 2.32794. Okay, what's R2? R2 is right here. R2 is the N2 minus 0. N2 minus 0 means N2. What is N2? So this R2. R2 is equal to V N002 minus 0. Because 0 is ground. That's why we have this 2.669. All right, let me help you with R3. R3 is right here. So R3 need to be N2 minus N3. N2 minus N3 is R3. It's a VR3. Sorry, it's a VR3. N2 VN2 minus VN3. If you refer to my diagram here voltage is higher than this voltage, right? Starting here is 5 volt and then drop to 2 point something and then drop to 1 point something. After each resistor, the voltage will drop. So we should take N2 minus N3, not the other way around. It should be N2 minus N3 because here voltage is larger than this voltage. Because current going this way, we should take the N2 minus N3. Okay, this current is wrong also. This current by the simulation is going to the left. Actually, it's go to the right. Because this simulation they don't care actually. They just based on whatever setting they have. So the this current entry is a negative. Just now we already confirmed the IR1 is a negative. IR1 is negative here, so that is going the other way around. It's going the other way to the right. So N2 minus N3 is here. V N JoJo 2 minus V N JoJo 3. Refer to your result here. 2 minus 3. Let me get the number out. 2.67206 minus minus 1.21457. So I'm getting a 1.4 something, 1.457. 1.457 volt. 75. Four decimal places is okay. I hope you can do the rest. Don't forget to insert the V. This is not R1, this is a VR1. And change this to subscript. Okay, now after I done here, remember I still need to fill in my number here. R2 is so voltage across R2 is 2.6 something. R3 is 3 here. Need to redo it. 1.4575. Because here saying that using a volt, so I don't need to key the volt again. Okay, because here is already indicate is a volt. All right, how about the currents? The current flowing through R1 in this direction to the right direction. The current to the right direction is R1. I hope you can see the small R1 here. But when we back to the simulation, is to the left. That's why it give you the negative result. It give you this negative result, IR1, negative result. So we need to take away the negative, become positive, 2.32794. 2.32794. Exactly same with the voltage. Okay. So let's take this number, divide by this number. You get 1K. 1K ohm. I need to borrow the symbol ohm here. But to 1K is okay lah, 1K. Because here say ohm already. Here already say K ohm. So I just put in 1 is 1 enough. Okay, let me complete the R2 for you also. R2 according to the result is 1.11336. 1.11336. 1.11336 milliampere. So this, let's divide this number, divide the voltage by the current using the Ohm's law. 2.67206 minus 1.11336. I get 1.8. Something I get is incorrect. Let me double confirm R2. 1.11336. let's do one more time. 2.67206 divided by 1.11336. So I get about 2.4, 2.39999. 2.39999 k ohm. So it's really similar to the my resistor here, 2.4. If I take this number divided by the current flowing through, what I'm getting must be very close to the resistor value here, which is 2.4. Okay, something I can tell you is that for the alpha, alpha is connecting between 0 and 0. This point is 0 watt. This point is 0 watt because of ground. And you should know between 0 watt and 0 watt, the voltage across will be 0 also. 0 minus 0, you get 0 watt here. When you get 0 watt, you get 0 current. So alpha is 0 watt. Current also 0. Just put 0 is okay lah. Okay, we don't want to no, emphasize so many 0. Just put 0 will do. The count value here, 0 divided by 0 cannot calculate. Because 0 divided by 0, we get nothing, right? 0 cannot divide by 0, right? Okay, so you take your time to fill out all the empty boxes here. Take your time, okay? Because I cannot show you all the answer. You still need to do it yourself. Some of the boxes you need to do it yourself. But the one I key in right here is confirm correct actually, based on my previous result. So I copy it. After I done, I copy it and paste under the table 1. Table 1 usually we put on the top here. We put table 1 on the top here. Or if you want, you can also put in the center. Okay, do it like this, everyone. Step by step. When it comes to engineering, the test result is very, very important. So when it comes to the engineering, professional engineering, the test result you need to treat very seriously, because we need the result to do the analysis and then to draw the conclusion. So you need to pay extra time on this test result. Make sure you're doing a nice job. Okay, let's see the next step here. Using the Kirchhoff and Ohm's law, determine the theoretical value. So on the following two tables here, table 2 and table 3, we need to use our own calculation, hand calculation, to find out what is the theoretical value, and then we need to compare with the simulated value. Simulated value is the value where we are getting from the LT spice. Theoretical value is the one we calculated using our hand. So we need to compare side by side whether it's correct or not. So how to derive the equation for these theoretical values? Okay, I can show some. I'm going to share you some lights here. Show you some lights. How to do this theoretical value. To do this, I need a digital pen. Hold on, let me get my digital pen set up. All right. To complete the last part here, using the Kirchhoff and Ohm's law, the last step here, let me point into here step number 5. Insert into table 2 and table 3. I think I should follow table 1.1 because this is LAB1. Here is the LAB1. Here actually it's called the LAB1. Because we still have LAB2 and LAB3. I think I need to start from 1.1 to show it's the LAB1, I think. Because later LAB2 I can have 2.1 something. Let's change it back to follow the lab sheet. Save it. This looks like this spelled wrongly. Kirchhoff. Should be K-I-H. Kirchhoff. This one spelled wrongly. All right, guys. Let me show you the how to let's remove this one. Okay, first I borrow the circuit from here. I borrow this circuit. Okay, so for the thing we have just learned, even though you have less experience right now, it's okay. For the KVL, we use the loop 1. Current is a knot, KVL is a loop. So what I see here, from here, the VS is negative. Start from VS here, I see a negative. Start from this point. Start from this point, when I go up, I see the negative. So I say negative VS plus V1 plus V2 plus V5 is equal to 0. Sum of the voltages must be equal to 0. And then from the result, we know so many things already, so it's easy for us to compare. So the VS, the power supply we set to 5 volt. This one we know already. And the V5 is equal to 0. We're quite sure because connecting between 0 and 0 here. So we are quite sure V5 is 0. So this reduced to -5 plus V1 plus V2 equal to 0. Okay, we move the 5 over. V1 plus V2 is equal to 5. Okay, we use this one using Ohm's law. Using Ohm's law, V equal to IR, VIR. So this one equal to I1 times R1 plus I2 times R2 is equal to 5. Okay, R1 and R2 we already know. R1 and R2 is 1K. Let's rewrite thing 1K I1. Well, 1K I1 looks really really strange. Let's put 100 I1 plus R2 is here 2400 equal to 5. So this is our first equation. We need another equation to find these two unknown, I1 and I2. Because we need to compare, remember, we need to compare it with the simulated value. Okay, we need to calculate. This is our hand calculated value. This one also. Simulated value we already extract from the LT spice. I show you 3 here. 1, 2, and 3, 0. You need to do 2 more. This value we already getting this from the LT spice. It's called the simulated value. So now we got only one equation ready. We need another one to solve two unknown. Two unknown, we need two equations. Okay, so the other equation must be coming from the KCL. Okay, the other equation coming from KCL. Let's looking at node B. At node B for KCL. KCL look for the node. KVL look for the loop. So we look for this node here. Okay, current in, current out, current out. One more time. I1 in, I1 entering, I2 exiting, I3 exiting. So it's really simple. I1 equal to I2 plus I3. Because this entering, this is exiting. Okay, this is another equation here. I3 equal to I1. Okay. So we can rewrite this thing as I1 minus I2 minus I3 equal to 0. So this is our second equation. Okay, this is our second equation. Okay, now look at the loop 2 here. Loop 2. This is a loop 1. How about loop 2? Let me extend it a bit. Extend it. KVL at loop 2 right here. Okay, V3 minus R2 minus R2, sorry, minus V2 plus minus V2 plus positive V3 plus positive V4 equal to 0. Plus V3 plus V4 equal to 0. Okay, let's change to Ohm's law. Minus I2 R2 plus I3 R3 plus probably we don't need this actually. Probably we don't need this. Plus V4 minus out V2, V3, V4 V2, wait a minute, V2 is V2 is 2400 minus 2400 I2, here's I2. Okay, this I2. And I3 is V3 is, where's V3? Here, 1.2K, 1.2K. Okay, plus I3. Here's I3, right? I3. Plus V4, 1K, I4. But you see, this current and this current is the same. This current flowing through this, going to the ground. This is not a node actually. This is not a node. You cannot say current going in, current going out, cannot, okay? Because this current is go directly to the ground. This current must be similar to this current. Because in one loop, the current must be similar. This current is different. This current is between here and here. The current flowing through R2, you need to take into account this current and this current. This current minus this current. Okay, but for this current flowing through here and flowing through here, I mean the R3 and R4, they are the same. So we can call them out I3. Let's rewrite the thing here. Okay. I2, I3, I2. Here got I3, I2, got I1. Here got I1, I2, I3. So we need to take these three equation. Take this three equation, 1, 2, 3, and then you solve for all, because three unknown. 1, 2, 3. Three unknown, three equation. You can solve for the unknown using the mathematic way. But this one take a while, okay? Take a while, because at least you got sufficient equations. Now you got three unknown. You got three equation. You can actually solve for the I1, I2, and I3. Okay. After you solve for this one, you compare. Let me save this one. So after you solve, because we have limited time here, I'm going to leave you to solve this three equation. If you forget, you can refer to your secondary school mathematics. How to solve for three equation, solve for three unknown. Let me help you a bit. You go to Google. I'm sure there are somebody will teach you how to solve this one. Solving three equation and three unknown using elimination. There are so many methods you can use, probably one or two methods. Okay, solving system of three equation, elimination. Solving system with three equation with three unknown. You can watch YouTube or something, and to review how to solve this one. Okay, I'm not going to show you. I'm going to show you right now because this one will take a bit, take some bandwidth from the our meeting. Okay, at least I show you. You got three equation. You can solve for three unknown. All right. Then you need to compare. You come to here. Come back to here. Copy these two table. And put under this number 5 here. Put under number 5. You need to fill in the data also using the MS Pen. Fill in the data. The other one here. This is compare the voltage. This is compare the current. After you solve for the current, then you can solve for the voltage. You need to solve for the current first. First step, you solve for the current. 1, 2, 3. This one is 0. You solve for the current. After you got the current, you use the current value to solve for the voltage. Okay, you can put in here to solve the voltage. V1 plus V2 equal to 5. After you find the V1, V2 is easily calculated from all this equation here. Minus V2 plus this one equal to 0. After you know V2, you know V3, then you can calculate the V4. Okay, you got to try it first. I'm not going to show every steps. I want you to try out yourself. Including the first equation. This is the first equation. 5 watt plus this one plus this one plus this one equal to 0. This is 5. So this is another equation here. Okay. So you actually have sufficient equation for you to solve for all these unknown by hand. Okay. Then you compare with your simulated result. You fill out the form here, and then you need to answer this question. You copy this one, to your red report here, remove the 6 here. So here is for you to answer the question. Okay, so what you do here is, if we change the polarity of the voltage source in figure, what's the number? Figure 1.3. Where is 1.3? It's figure 2 actually, figure 2. Suggest the value for each. You just answer if the polarity and okay, put out your answer here. What you can do is you can come back here and change this one. You put this one upside down. You rotate this symbol. You put the negative up, positive down, and then you run the simulation again, and then you observe the result. Then you can answer this question. Okay. Determine the next one is to determine the relationship among the VS. I think this one you know, right? What do you mean? What do you mean relationship? You can the relationship can be defined with this equation. Using an equation to relate their relationship. Okay, using this one to determine their relationship. This one is only 1, 2, 5 and VS, all right, without V4. So you need another one. You need another one. Okay. I think I already show you enough information how to answer this question. Then after the question, followed by the after the question, what you need is the discussion. Try to do a proper alignment here. How come this ones go all the way in here? Okay, after this discussion, after discussion is the conclusion. So how do you discuss? You can say something like this from the simulated results getting from okay, you can discuss. After the conclusion, you can say something like this. Okay, you can refer to some other test report to see how they write the conclusion. Okay, what's some conclusion here? About one paragraph should be enough. Okay, if you have more to talk about, then you can write more lah. Actually, discussion, usually we discuss about the test result. Conclusion is a kind of like overall about this the purpose of this experiment, which is the Ohm's law and Kirchhoff's law. Okay, usually discussion we talk more actually. In discussion, usually we talk about the any differences between these two results. Any we call it conflict or anything, or disagreement between these two results. There's one word called the discrepancy, I think. There's one word called, if I remember correctly, discrepancy. An illogical or surprising lack of compatible or similarity between two or more facts. Lack of similarity between two or more facts. Similarity, discrepancy. Okay. You can actually, when it comes to the discussion, we can discuss about the LT spice. We can discuss about the test result, the law, and the problem you face out when you do the simulation. And you can also discuss about the simulation you use transient to check the current, to check the current direction, to check the direction of currents. And you can talk about using the simulation DC operating point, using the DC operating point to easily come up the quick result like this, the quick result like this, right? The quick result. But the problem is sometimes we are confused about this negative polarity. Then we can switch back to the other simulation mode, switch back to the transient. Then we can find the currents and run. After you run, you can find the direction of the current. You see the red arrow is the direction of current. Okay. Then you can compare with the DC operating point. Then you can understand the meaning of this polarity. Why they say it's a negative. After you convert, I think all of them should be become positive. It's just the initial assumption of the software. The current is going this way. That's why they sometimes they produce negative value here. So we just need to verify what exactly the current is flowing, where exactly the current is flowing by a double check with another simulation mode. Okay, then we can show that I2 is actually flowing the other direction. But don't be too overwhelming about this negative sign. Sometimes it's just showing that the current is flowing the other direction only. Let's say you say it is going this way. Oh no, it's going the other way. It's just as simple as that. Just a really simple indication only. There's nothing more to talk about actually the negative. But for the beginner, when they see the negative sign, they are kind of a bit panic. They don't know what this negative sign means actually sometimes. But to us, when we see the negative sign, it means the assumption is the assumption of the direction is wrong. Initially, we assume the current is flowing through this way, but when we run the simulation, actually the current is going the other way. Okay, but you know that when we do the analysis by hand, sometimes we assume the current this way, right? But actually, when you do the experiment, it's going the other way. Just for example only lah. Okay. because we can always assume the current in this direction, then we write the equation, right? If you get the negative value, means the assumption is wrong. This will be the other way. Then we just change this arrow, After we got all the value, we make sure it's all positive or all negative, then we change the value. We change the direction of this arrow. After we find all the exact values of the currents, then we can adjust back this arrow. Okay. So we're going to take about 10 minutes break. When we come back, we need to complete the other lab number 2. Right now, what I'm showing you is lab 1. How many? We got 8 pages already right now. We got 8 pages, including the 3 empty one. We got 8 pages of document right now, starting from the introduction, procedure, questions, discussion, and conclusion. So the next one will be our next 2, lab 2. So I create another page break here for the lab 2. So for the one you need to complete yourself, the discussion, the conclusion, you need to complete yourself. I cannot show you the answer, all the answer. And this one, the empty boxes, also need to find out yourself. You need to calculate your own value and then compare with the simulated value right here. Here is all the simulated value. Okay. Using LT-SPICE. This one is using the hand calculated value. Okay, we take a break now. We come back 10 minutes later. All right. So suddenly got so many questions. The ground symbol here, you put your cursor on the top of this icon, you'll show the name. Or you come back here, here's for the others components. If you put the cursor on, you can see the name. Okay, so we choose the voltage source here, voltage source. All right. So some some student, they suggest using the Command G. Command G can bring out the ground. Let me try. Let me try if this is true or not. Okay. I type G. Oh yeah, type G. I type G, it appear. Type R, it appear. I type G, appear. I type V. Oh, so this is a shortcut lah. Okay. You can type the word G, R, V, I, no I, L, C. Okay, you can play with this one, but so far I just get the parts from here. Okay, so this is a good good advisory. You save your time to look for the component. The value of alpha, the value for alpha, alpha, even though there's a value here, but alpha is connecting between 0 and 0 volt. So there's no current flowing through. So I5 is 0. When you back to this simulation here, where can you see the I5? There's no I5, right? No I5. I5 is 0. V5 0. V5 0, I5 equal to 0, right? Okay, so there's no I5 actually. if you really want to put I5 here, it should be 0 volt, 0 ampere. Okay, we come back later. Minutes break, guys. Okay, I'm coming back. I hope you can see the screen again. I want to show you something like this. This is all I want to show you. You see, this is how we grade your assignment. This one we cannot. We have to grade you based on your introduction, whether your introduction is good or not. And then we also do the grading on your procedure. Do you actually list down all the steps in detail, or you just some of the steps are missing? If the steps are missing, then you get 2 points here. If all the steps is there, then you get 4 points. Okay, and so on. And about the results, if the results contain the error or the result are good, graph table correctly, everything correct, then you get maximum 4. Okay, and you see we have 2 more sessions. In the previous semester, those students they forgot to include this discussion and conclusion. That's why when I come to this point here, I need to put 0. You know why? Because I cannot find the discussion and conclusion. I cannot put a point here. So this one will drag down your grade actually. So I need you to pay attention here is in your reports for every labs you need to include the discussion and conclusion. Okay. Without these two, you'll get a 0, and then the marks here is quite high also. You can see we call the weightage here. The weightage here is 7.5 and 3. So the discussion is 7.5. Discussion is more important, about equally important as the results. The result, the weight is 8. Okay, 8 points. Discussion 7.5, very close. Conclusion is just a very small number here, 3 points only. Almost similar to this introduction. The step is 4 points here. So altogether is a 15 point for this. Altogether is a 15% for lab number 1. This is how we grade your assignment based on the so-called this OBE rubrics. A rubric for the assessing a lab report. Okay, so you make sure you complete, you fulfill all these requirements here: introduction, procedure, result, discussion, and conclusion. That means I want to see in your report. Okay, if I want to give you a good grade, I want to see it in your report. The questions, I think the question is under these results. Question is under the results. Actually, the question came under the discussion. Question is really similar to discussion actually. It asks you something really similar to discussion. So I think I will group these two under the discussion. Lab question will not answer. Yeah, it's under the conclusion. Sorry. According to this rubric, the lab questions will not answer. So you get 1 point. So if you answer the lab question, clearly answer, then you get 4 points. So it's under the conclusion, 3 only. So make sure you do that, okay? That's what I'll try to tell you many times here, because many students they forget about these two steps. Because these two steps is not in the lab manual. You can see here, it's not in the lab manual. People just skip these two steps. But if they pay close attention, you can see that it's right here. Okay, it's right here under the reports. In other words, this assignment question 3 is in the report format. But you can put it in like just like what I show you here. You can put it in together with other questions, like question 1, question 2. Okay. Question 1. This one you need to change your name, of course. You need to change your name. Master 1 and your student ID. I think this should be the one. And then your I think 5 is from Penang or something. 5 is from KL or Ipoh. Total pages. This is my name. This is the name of CC. Okay. This is the class code. You need to follow your class code where you come from. Example, if you come from JB, the code start with 7, just like the telephone code 7. The one coming from Kuching, the code starts with 82. Then you do question 1 in sequence, question 1, then followed by question 2. Don't jump the sequence, because sometimes we can miss reading your. If you cannot find the question, then you may receive a 0 mark if you cannot find the question. So you make sure you put all the question is in sequence 1, 2, 3. All right, now what we're going to do now is the next lab. Okay, let's begin. The next lab is dealing with the Thevenin theorem. So we just put down question 4. Question 4, 15 marks. Lab 2. All right. So the next thing to do is introduction. Let's see what introduction should we put in. Basically, just a Thevenin theorem. Very short one. Let's say we borrow this diagram. We just borrow it over. Then let's do a proper labeling. Figure lab 2, right? So lab 2 is a 2.1. Okay, then we discuss something here. Just borrow this. Let's see anything we can borrow here or not. I think we kind of like can borrow the namely the fixed circuit and the I think we need to have these two. Okay, let's have these two in the report here. Or you can do your own also can. You can go to the website. You can try search for the Develin. Develin. Let me try. Let me try. I can get some kind of a definition from here, no? So the way how they explain is different. It's possible to simplify any linear circuit, no matter how complex, to the single voltage source to the load. I think this is a kind of like put everything in one sentence. I think you can borrow this sentence they have here. This Develin theorem is quite general knowledge already, so you don't need to worry about all this we call the plagiarism, because all this is considered general knowledge. Okay? It's not someone's idea or something. But if you want, you can put down the citation also below, if you want to protect yourself, because this sentence copy from someone else, right? If you want to protect yourself, you can put the reference at the last page there. It's possible to simplify any linear circuit to equivalent circuit. Then you can go on to explain it, okay? You can go on and explain it. Usually, any circuit consists of fixed and variable okay, you can go on to explain it. I'm not going to spend some time try to explain it, okay? Because I think you should try to do it yourself. Introduction about this Develin theorem. At the same time, you can do some review also. So the next one we need is the procedure. Make sure you're using the same font type. This is quite important. Make sure you're using the same font type and size also. Okay, for the procedure, we can copy straight away. I think it's okay. It's not considered the plagiarism because we just follow the procedure. So I better use the bullets here. Use the bullet here. So it asks us to construct the circuit here on the figure 2.1, 2.2. All right, let's copy the circuit over. All right, let's do it one more time. Resize it and label it. All this step we cannot skip. All this is quite crucial. Quick, slow and nice. Okay, now we just go ahead and draw this on the LT Spice. And I'm going to rename this one. I'm going to save this as the let's see, I can find the LT Spice folder now. Okay, I save this one under the LAB1 ECP LAB1. Okay, later on I can come back here and double check sometime. Okay, let's create another new one. Let's close the previous one. Create a new one. Let's call it ACP Lab 2. All right, now we are almost done. Let's press the V. We press the V, the thing appear. One more time. You press V, the thing appear. You press Control E. Hey, wait a minute. One more time. One more time. Press V, Control E to move this around. And then we need 3 resistors, 1 horizontal, 2 vertical. So I press R, press Control R, rotate slightly above, 1 horizontal, 2 vertical, rotate. Okay, and we need ground, of course, we need 3 grounds. Ground is G, press G, put right below the each component. Use the grid, use the dot here, the grid as the guideline. Okay, now it's simple. Now we just need to join the line using the wire. I think you can press wire, press W. Join the wire. Try to. Okay, luckily just now the R1, R2, R3 in the same location. R1 is here, R2 is here. So make sure your R1, R2, R3 is in the same position. You cannot reverse their position. Later on you can get into trouble. Okay, just follow exactly same as the lab manual. I hope you can get it done easily, right? After the first lab. I think after the first lab, I think everyone can get it done really quickly. So the next thing, of course, is to put down the values. 12 volt. Left click. Put 12 in front of V. And this one is at 1.2K. So you left click. Type 1.2K will be enough. Don't need the R and the ohm. 10K 3.3. Just do the same. 10K. And 3.3. Okay, I'm going to stop for a while. Let you catch up a bit, okay? Because some students may have some trouble. So by now, what I can see, I have one V1, R1, R2, R3. Here is called the 12 volt. It didn't say any V1, V2. And then again, it wants us to do the DC operating point simulation. By pointing the node to check the voltage and the mesh to check the current. Okay, let's do that. Let's do that. I think most of you can catch up now. Let's come back here. Let's go right to the simulation. Simulate. Oh, how come this thing? Then we click command. We choose the last one, DC operating point. Click OK. Put down this right at the corner there. And then run. Click the running man here to run it. And then we'll get this result. So according to the lab manual, he just say according to the lab manual here, pointing at a node to check the voltage. So we're pointing at the node. I don't think we can check the voltage by just doing that, because this thing keeps flashing. So I think what the lab manual means is we need to change to the another mode. Change to another mode here. But before we do that, just copy down this this table. Before we do that, reduce this a bit. Run the simulation again. Then we can copy a nice table from here. Use it as our test result. I hope the value is correct. Let me double check. Let me double check whether this value is correct or not. Looks like it's correct. Looks like it's correct. Okay, then we can continue. Let's put it down into our lab report here under the tool. So let's copy the next. Let's copy the next step here. Record down their values, pointing at the node voltage and the currents, and record down their value Eiectric. So I just copy over the result here. Run the simulation result. Run the simulation by performing operating point. So I think I should put this one on top, because this should belong to the step 1. This result should belong to the step 1, not step 2. Step 2 is to pointing the node and get the result. So for step 2, we need to key in this result here, I3 and VR3. So what I'm going to do is I'm going to copy these two. I'm going to copy these two line, and I put here. Later I can fill in the number. But first thing I need to change the simulation mode back to close this thing. We need to change to transient analysis here. Just put in some value, 20 millisecond. Stop. Start is the 0. And time to the maximum time step is 1 millisecond. Okay, so this one will translate into this line. This is a shortcut. So you click OK. This line will place here. Then this thing remark. The mean operating point is disable. This thing disable. The one with the dot is enable. Okay, then we can just run it. Then you can see the same thing appear again. Now put our cursor on R3, right? R3. Let's put our cursor here. You see the probe, click here. It's 8.088. So we come back here and key in the value The first value we got already. Okay. Let's see that the next value here is the current flowing through the R3. So you move your cursor on top of the R3. You can see the cursor pointing up. The cursor is the red arrow is pointing up. You click. You can see the blue line. Blue line referred indicate by this IR3, the blue line. You read on the right hand side here is a 2 point something. We can't exactly pinpoint the value. If you move around your cursor here, you see this. You can see the number here is changing. So we can not easy to pinpoint the value here, but we can rely on our first operating point value. You go back. You look for R3. Is in ampere 0.0024. Translate to 2.451 milliampere. R3, right? R3 negative sign because it's pointing upwards. Because it's pointing upwards here, you see, it's pointing outwards. So it gives you the negative sign. So if it's pointing downward, it becomes positive. According to our LAB manual, it's pointing downward. There's no pointing up downward. But we assume it's pointing downward. So what I mean is, like this. On the PC Spice, the current is pointing outwards. Okay, this is very ugly, right? Let's change something. In the LT Spice is pointing outwards. Okay, and then it gives us the value of negative 2.451 milliampere. So this negative value means that when pointing downwards, it should be positive. It should be positive. When pointing downward, it's a positive. That means that the current is actually pointing downwards, not like the LT Spice is pointing outward. So actually, it's pointing downwards. Pointing downwards, no negative value. Pointing outwards, negative. LT Spice showing pointing upwards. That's why I give the negative value here. You give the negative value here. But we as a human, we know that the current should be pointing downwards, pointing to the ground. From here, start from positive all the way, going through this, and then flowing through the R3 to the ground. So this is pointing downwards, 2.43. So on the test result here, we should put down as a positive value, not the negative value. Okay, we put down this. And then we just copy this thing. Let me double confirm again the result is correct. Okay, we copy this thing here. Copy the nice result to our step 2. And resize a bit to match the font here. Because we don't want to give people impression that we are doing a sloppy job. We need to showing that we are professional. Our text size must be somehow matching. All right, now we come to the step 3. I hope you can follow. Let me read your comment, whether anyone looks like everyone can follow. If you cannot follow, you need to let me know so I can slow down a bit. Okay, let's see the next step. Now, by using Thevenin theorem, we calculate the current through the R3, and procedure is given step by step. Show all the work in the space provided. First, we calculate the VTH, then we remove R3 to find the voltage. Okay, actually, this step wants us to use our hand to show all the works, to calculate the Thevenin voltage, and he wants us to calculate the Thevenin voltage. You see the calculated? This means we need to show some kind of work here. The Thevenin voltage. All right, we want to measure this Thevenin voltage here, not by simulation, by calculating. We remove R3. So we need to remove this one and calculate the remove R3 and measure and calculate the VTH. Okay, let's copy the whole sentence here. Let's copy the whole sentence because this test report actually is to show people how you conduct the experiment, and people need to know the every step. Okay, let's copy this thing here to the step 3 here, so it looks quite okay. Need to remove this noise here. All right, then we need to borrow this figure 2.4. Borrow the figure 2.4 here. Just use the same figure number. I think should be consistent, right? Adjust the size a bit. Okay, now it's the time for us to calculate the VTH using what we had learned in the classroom. To calculate the VTH, okay, let me show you here. Somehow I need to remove this one. Okay, let me redraw this one a bit. How I'm not taking too much time right now. So we have 1, and the other one is 10K. Okay, here's a node, here's a ground, 10K, 1.2K, and then here's our VTH, our Thevenin voltage, so-called. Okay, as you know, the VTH, actually VTH voltage is this voltage. It's a 10K voltage. It's a V10K voltage. All right, because the same node here. This node is same with this node. This node is same with this node. It's just a wire here. So this is actually a voltage divider. This actually called the voltage divider. So the voltage for 10K, we can use this formula. Let me try. V10K is equal to 10K over 1.2K plus 10K, and then multiply by the voltage, 12 volt. This is a voltage divider circuit actually. The voltage divide into this and this. Okay, so we are at this portion here. This portion is larger. This is 1.2. This one is about 10 times more than this 1.2. About 10 times lah. This is about 1K. This is a 10K. So the voltage here must be 10 times this resistor. Okay, the voltage here should be much larger than the voltage here because here's a 10K. So I use this formula. We sum all the voltages, we sum all the resistance, and then the voltage for this 10K should be this. The ratio should be like this 10K. So let me calculate this. Let's start from the denominator. 1.2 plus 10. Then we take the reciprocal. Okay, and then we multiply by 10 multiplied by 12, so we get 10.714. we get so you can check this visually, 10K and 1.2K. To share the 12 volt, of course 10K can get more, right? So 10K get 10 volt is the logical. You can visually check the result also can. Okay, visually can quick check whether your result is correct or not. So I'm quite sure this is a correct answer. It's quite logical. Okay, let's back to our test report here. We need to fill in the VTS, right? Okay, let's copy this thing. Actually, is I think the time we use is about the same . If you create your own or you copy the thing here, it's about the same. Okay, so we just write down our answer. 10.714 volt calculated, right? So in order to show that this you calculate this one is not, you are not getting this from the simulator. Somehow you need to show this, the steps how you bring you to this answer. You need to show this one in your report to prove that this result is a hand calculated. It's not the so-called the simulated result. Okay, copy these two over, resize it properly. Slightly smaller a bit. Okay, now we can continue to the next step here. Step 4. I hope you can follow. Or somebody say that or somebody is leaving, probably they got something to do. Somebody said that the window for the Mac is not the same. I'm not so sure actually. Okay, I'm not so sure because I haven't using any Mac PC before. Okay, let's try to do the next one. Verify the simulated result here. So this step is quite simple. We just need to get the result from the LT spice. Okay, the result from LT spice is, you can just later I'll show you. So we come back here again. Actually, we can remove this 10K. So we need to using the scissor and cut away this component. Okay, so this will be our VTH. Okay, then we run and we take away this one first, delete. We're pointing our probe at this node here. So we're getting a 10.714. Exactly the same. So if you want to read the exact result, you need to change it to DC operating point and run it. So the VTH is 10.7143. Let's copy this result table. Let's copy this one to as a proof. The proof that you're getting the result from the LT spice. How come this will become A? Okay, now let's borrow the this line here. Let's borrow this line. Using the snipping tools, let's borrow this line. Okay, let's key the simulation result here. 10.7143, more decimal point here. Let me write down. .7143 volt. Okay, and then copy and paste again to the lab report and resize it. All right, so this will be our step 4. Construct the circuit in 2.4. Here, same circuit. Using LT spice and record down the VTH here. You can write down something. You can write down some more information here. You can say that VTH. You can say that VTH let me cancel this one first. How come this is not subscript? But the font size becomes smaller. They change the font size. They change the font size here. VTH is equal to V02. I can put down more information like this, okay? Change this one to 8. This is another way to do the subscript. Okay? All right, VTH actually is the N002 here for LT spice. All right, now we need to find the RTH. This is simple, right? RTH. This is just two parallel thing, right? Two parallel. But now we need to doing the calculated one, calculated value. First, let's copy the step. Copy it. Put down here. Everything looks really nice. So we need something called the figure 2.5. Okay, let's copy this thing over. Let's copy it. 2.5, including the title. Okay, and then too large, resize it a bit. Okay, right now what we need is a calculated value. So we need to calculate this one. Put it here. Move this one over here. Now we're dealing with only the resistance circuit. We take away the voltage source, leave us with the R1 and R2. R3 also taken away. So it leaves us only the R1 and R2. So we need to calculate what is the total resistance for this circuit. Okay, this is very simple, right? I think you can do it yourself. You can using the formula I use, the formula I showed in the classroom. First, we multiply these two values. Then at the denominator, we just add these two values. We add these two values. This equation is really only apply for two components. If you have three components, you cannot do this. This only apply for the two components. So let me get the number out for you. Let's start with the denominator. 1.2 plus 10 reciprocal multiplied by 1.2 multiplied by 10. You get 1.7143. 1.7143. Let's write down here. Okay, and then we copy this line, the Thevenin resistance. Here, calculated value, resize it. Okay, of course we need to show the step, because in order to get the full marks, you need to show the step. In order to get the full marks, you need to show the step. Don't forget about the symbol and the unit. The unit. Okay. Copy your step, showing that this is your work. You are not actually copy from somebody else the value. these things without the K ohm. Okay, I think we are now almost done. We are now left to do is the simulated result. How to get the simulated result? So the RTH here need to the value here need to obtain from the LT spice. You can follow the instruction here by using this theory here. You know the when it comes to LT spice, you can have currents, you can have voltage. When it comes to the result, you can have current and voltage, but you cannot get the resistance value. You cannot ask the LT spice to calculate the resistance value here. But there's a trick also. There's a trick you can apply. It's based on the theory. It's based on this theory. Let's say you got one resistor unknown. You want to measure what is the resistance value here. It's unknown. But you can actually measure it using the current and voltage. Let's say you apply 1 voltage here. Let's say you apply 1 volt only. You must using only 1 volt. Because, for example, let's say this is 1.2 K. If you apply 1 volt here, there will be current flowing through. The current will be equal to V over R. Okay, and then the R will be V over I. So if you get the current here we can calculate, right? For example, this is unknown. I put a bracket here to tell you this unknown. Let's calculate the current here. Let's say we don't know the resistance here, 1.2 K. But you build the circuit up, and then you calculate it. 1 volt divided by 1.2 K. 2K. 1 volt divided by 1.2 K. So you get 8 point multiplied by 1000. You get 0.83 milliampere. So here you get 0.833 milliampere. So the R value, the unknown R value, can be calculated using 1 over 0.833. The reciprocal here, you can find that value is 1.2. Okay, that means we can use this technique to solve the RTH. Okay, let me show you how. It's exactly described here actually using the 1 volt. So what we do is we cut away this thing. Okay, cut away this. Take away all. We need a ground also. Sorry, we need a ground. And then we join the wire. Exactly like this. Okay, now we use the LT spice. Oh. Okay. Let's do it nicely here. First, cut away this thing. Okay. Then I press the G. I put the ground here. And then I take the wire. Okay. According to the procedure, we need a 1 voltage source, 1 volt. Hold on. Press V. Set to 1 volt. Okay, and then join the wire. Oh, one more time. Okay, then we measure the current. The current will be equal to the resistance, okay, because of 1. Now let's measure the current. I think right now is the DC operating point. So the current here is a 0.83. The current 0.83. So the voltage is the resistance equal to V over I, 1 over 0.83. Okay, let's measure the current here. The current flowing through the V1 here. Current flowing through the V1. Let's change this one to transient. Let's measure the current here. The current flowing through the V1. 0.9 something, right? To get the exact value, change back to this operating point. Run. This value actually 0.00093333. Okay. So we need to take 1 over that value. Let's do it. 1 over 0.00093333. So you get 1.714 K. 1.714 K. Our simulated result. 1.7147. 1.7147. Let's borrow this one, the simulated result here. Let's borrow this line. Let me change back to the data we have. So the current measured by this the current is so we don't need this anymore. What we need is this one. Is 0. Let's copy the result here. Copy the result window here. To show that this is the result we're getting and copy this line also. Okay, we get 0.0009333, right? Back to our worksheet here. So you get 1.07146 K ohm. Okay, let's copy this. Copy the whole thing here, including our steps. To our report. Put it right below the test data. Then this the result, the simulated result using the LD spice to get the resistance. So this value is getting from the simulation software. It's not the calculated software. This is the simulated software, simulated value. Let's compare with the calculated value. It's really close, right? This one is 7143. This one, using the technique we use, we're getting a 1.7146. So it's better to also show this this circuit also. Just cut and paste only. We don't need a lot of work actually. Just cut and paste the result. Okay, here's 2.5. Now here should be 2.6. And this one should be table also. You should call the table. Just now I forgot to put the name here, right? Table. Because every figure you need to actually put down a name actually. You need to label the table also. I think just follow this will be better, I think. This is table 2.1. Table 2.1. Figure 2.4. Because we cannot just leave anything without any label. When it comes to the report, all this is really important. Everything we put in, we must have a reference. Otherwise, you'll get a lot of comment later on. I think it's 2.3. Table 2.3. Actually, for table, usually put on the top. For figure, they put at the bottom here. For table, they usually put on the top. Whether to centralize it, I think it depends on sometimes. Sometimes people prefer to centerize the table here. Let me go to Google a bit. Let me see if I can find any to make sure this is a common practice or not. Let me try to find any common practice or not. You can see this one, they put the table in the center on the top. This one also on the top, but on the left hand side. I think most of people do that. Most of people, they follow this this center. The table always on the top, the label. So we follow the standard also. The figure is at the bottom. I don't know what's the reason why they don't do that, but we just follow, okay? We just follow the common practice. All right, I think we're almost done. We got the steps, how to come up with the calculated value. We got the how to use the LT spice to get the resistance, how to get the total resistance from this circuit by using 1 volt, and we get the current here. We can get this main current, then we can divide by 1 by this main current. We can calculate the simulated value here. Even though you won't show it here as the value, but you need to take this value and reciprocal the value, and then you get the final answer. Okay, now you need to draw the Thevenin equivalence circuit using the calculated VTH, using the calculated value, put into this box. Okay, we've got some more steps to go. Again, this is step number 7. Oh yeah, the recording later I will upload to the YouTube. But give me some time also, because the file is quite large. It's a few gigabytes. I need to upload to YouTube. Take some time. Hold on, let me see. Okay, step number 7. I hope that we won't get any supplies from this recorded video. I hope that my MS team can provide the download link for us later on. Draw the Thevenin equivalent circuit using the calculated value here. I'm sure you know how to draw, right? Thevenin's circuit. Okay, let's draw it here. First, we have Thevenin voltage. Let's get a good circle here and put the polarity, positive and negative. Okay, the name is called VTH, and the value is, we must get the calculated value, not simulated value. Calculated value is 10.7143. This is simulated. Let's get a calculated one. 10.7143 1.714. Okay, and then what we have now is the Thevenin resistance. This is the Thevenin resistance. RTH. This is the connecting to our load here. Okay, this connecting to our load. So RTH calculated value here 1.7143. K ohm. All right, let's copy this one to our report. Under the step 7. Okay, give a label it figure. What is the last number? 2.6, 2.7. Okay, so this step is done. Save it. Step number 8, based on the figure, calculate the IR3. Figure 2.6. So here's figure 2.6. Calculate IR3. Copy the line here. Okay, need to retype again. IR3. Change the font here to 8. All right, how to calculate IR3? He wants us to calculate. Let's come back to this circuit again. If you should remember what's R3, R3 is the one represent our load. Here, R3 is our load. External one, external. This is our Thevenin circuit. This is the external load. We connect to the external. So right here, we can connect to the external load here. Okay, because this part is called a fixed. Here is a fixed. This part until here is a fixed circuit. According to the introduction, and this part here is a variable circuit. So R3 is our variable circuit. That means the user sometimes they change the R3. This one is already in the system. This one is a fix. It won't change. It won't change from time to time. But the user will change R3 from time to time. So if the R3 is 3.3K, what will be the current flowing through R3? So IR3. So this one is another voltage divider, right? This one going to be 10.714 to be shared by R3 and RTH. So R3 will share the most voltage. Then the the total voltage here is R3 plus RTH. R3, because this voltage is going to share by these two components. So this one 3.3, of course, will take the most byte, the most bigger chunk out of this 10 volt here. Here only 1.7, almost half of this one. So this one take about, let's get the data out here. Hey, wait. We need to calculate the voltage first. Voltage, then we divide the voltage by resistance, we get the current. Okay, we cannot just do it in one shot. We have to get the voltage first. So this one is the voltage. It's not the current, it's the voltage. We cannot do both at the same time. So this is a VR3. VR3 you go through. Let's calculate that. I do the denominator first. 3.3 plus 1.7143, and then I need to take the reciprocal, multiplied by 10.714 multiplied by R3, 3.3. So I get 7 point something volt here. I get 7 point something volt here. Okay, let's calculate IR3. Let's see whether it's correct or not. I go to V over R. Okay, let's get this number out. Two point 2.137. Okay, let's copy the whole thing here. Just save some time. Copy the whole thing here to our report. Because while report 1, the calculator R3. Now we come to step 9. By using the LT spice, we get the R3. So we need to construct everything again. We need to construct everything again using LT spice. Let's copy this line first. Okay, how to get the R3? We need to construct this circuit. But he didn't say using what circuit. He said pointing a node to check the current. He didn't say what circuit. I think it should be this circuit, right? Looks like it should be this circuit. Okay, let's construct this circuit. This is step 2. This is step 2. Cannot. When we at step 9, construct the circuit in 2.6. Yeah, refer to 2.6 here. So 2.6 is this circuit. We construct this circuit and then we calculate the R3. 2.6. 2.6 is here, is empty. That means this is 2.6. Okay, let's create the key in the value here. We need one voltage source here, so we need to cut this wire. Okay, take this away. Cut this also. Now we need one R3 here. R3 is the new resistor. It represents the root resistance. Put the R3 in. The next thing to put in is the voltage source. Type of V. Join the wire. Okay. Take away the 10K. Take away 10K. Key in the value here, 10.714. 10.714. And then here is 1.743. Double check again. 1.7143. 1.7143. Okay, now we need to measure this 3.3K. 3.3K. You want to measure the current because there's only one current here. So we just run a simulation. So the current is 2.136. Is it similar? 2.137. Very close, right? The simulation results is 2.137. But as a proof, we do as a proof. Let's put this together and then paste into our report. Okay, because we almost run out of time, we need to make sure that let's copy this line. There's nothing here with for step 9. There's nothing we need to take down. Construct the circuit, insert the value R3, and calculate it for step 6. Measure the current. Here step 6, step 10 here actually. Step 10. Step 10. Measure the current through R3 and the voltage through across R3. So the data is here. So we just need to copy down these two lines, simulated result. Copy these two lines. And just need to key in here. But remember, this one must be come from the simulator. So the value is here. 7.05107. The voltage. 7.01. Is it 0.5.107 volt. And the current is 2.137. Okay, let's copy these two to this step under step 10. Okay, let's reduce this a bit. Getting from here, from this table. Okay, Let's see the step 11. Oh, no more already. Step 10 is the last. So now we have the question. Now we are reaching the end already. Luckily, we're reaching the end. Now take away the 11. Now we have question here. You need to answer the question, followed by discussion. So I type it in case you forget, and then followed by conclusion. You need to discuss something here, and then that's it. That's all for the LAB1. You see here, short introduction, procedure, result, discussion, conclusion. You should capture the result. You can use print screen. You must include the circuit diagram you constructed on the LT Spice. So we follow exactly the same the requirement here. So I leave this one to you. Okay, so I create another page break here. Another page break for the next lab, Norton. So we come back later, next round. In the next tutorial, we're going to start doing a 5, 6, lab 3, lab 4, lab 5. We need to complete 3 labs. That's why we have 6 hours waiting for us ahead. Okay, we need to do 3 more labs to complete the assignment number 2. But they want to not so difficult, don't worry. Okay, everything just follow the step only. So this is the question. Let's read it. Question what? 1, 2, question 5. Let's copy this thing, okay? Let's copy this thing. Let's copy these 2 lines and put it here. So this is waiting for us to do next week. I don't know what is next week about. Next month, I think. Next month. All right, that's all, folks. That's all we have to do for today. Luckily, we still have 15 minutes remaining. So if you have any doubts, you can go back to the video again. I'm sure the video is recording now. Almost close to 4 hours. So so far okay. Do you have any question you want to ask? Or you give me some time. Let me convert this one to YouTube. I paste on the YouTube. Okay, you are still here. Can you please type your name here so that I can do the attendance later on? Because sometimes to read this initial CZF sometimes it's difficult. All right, everyone. Any question? I'm waiting for your questions. Oh, I need to end this session now and start converting the file. All right. Looks like everyone can follow the. Okay, very good. So the last word, make sure you have this this form in the first page and fill in your name here. You can get this form from the LMS or the Flex Learner. They call it Flex Learn nowadays. They call it Flex Learn. WOUEDUMY. come here to get the form. Right here. TDF assignment declaration form. Here's empty now. Take in and fill in your name. And then try to follow execute the same, okay? Try to follow execute the same. So this is what we have done in 4 hours. And still, some still need your work also, like the conclusion, discussion, question, and answer. You still need to have extra work here to complete the assignment. So what I'm here is only helping you to get all the result and getting all the data. Okay, so you still need to do your own conclusion, discussion, and the question. Okay, this is what I have to do. I think we can say goodbye right now. Okay, I'll see you next month in lab 2. All right, guys. Okay, bye bye. Okay, bye.